SCGS Prelim paper for 2023, paper 2. Let's look at question 1. So for paper 2, you're allowed to use your calculators. The question 1, measure and write down the size of angle A. So angle A is over here. It's a reflex angle, so it should not be anything less than 180. Okay, but what you can measure with your protractor is the angle on the inside. So use your protractor, measure that, then you take 360 to minus that angle. So you should get 334 degrees. Okay, so 360 minus away the angle that you measure on the inside, you should get 334 degrees. Okay, question 2. Ken and Ben have the same number of sweets. Ken ate half of his sweets and gave half of his remaining sweets to Ben. After that, Ben has 35 sweets. How many sweets did Ken have at first? Okay, so since they have equal at first, let's start off with the model. Ken ate half, so we remove half. And gave half of his remaining sweets to Ben. Okay, so whatever that is left, to cut to half. And then this is for Ben. So transfer it over to Ben, that 1 unit there. Okay, so now what I'm going to do is I'm going to cut. This was half of the total, and we cut it into half. So here we cut it into half as well. So for Ben, we're going to cut the same number of units from the original total. Okay, so now all the units are equal. Ben has 35 in the end. So what we can see here is 5 units is 35. So 1 unit is 7. How many sweets did Ken have at first? Ken had 4 units, so we find 4 units. So answer 28. Mrs. Lim bought a blender at 20% discount during a sale. She paid $90.72, including 8% GST. So what is the original price of the blender? Okay, so here we have percentage discount as well as percentage GST. Treat them as 2 different types of percentage. The amount that was given is the final amount, which is after GST. So we should remove GST first before we remove the percentage discount in order to find the original price. So this $90.72 is after GST. Anything after GST, if it's an 8% GST, means that you're paying 108%. Okay, so 108% is $90.72. When we find 1%, then we'll find 100%. So 1972 divided by 108, which is 84 cents. Then to find 100%, 100 times 84 cents, which is $84. So this $84 is before the GST. Okay, we have not removed the percentage discount yet. So now let's talk about discount. If there is a 20% discount, it means that this amount here will be after discount, which is 80%. So if we talk about GST, $84 is 100%. But if we talk about the discount, $84 is now 80%. Okay, so it depends how many percent it takes on. Actually depends on what type of which of the percentage you're talking about. okay, whether it's GST or discount. So with the discount, percentage discount, right? Let's find 1%. Then the original will be 100%. So 84 divided by 80. $1.05, then we times 100. $105. Question 4. The pie chart and the table below shows the number of each type of stickers sold in two shops, A and B. So we are supposed to state whether it's true, false, or not possible to tell for each of these three statements. Okay, for first one, shop A sold 100 stickers. Is it true that 100 stickers are being sold for shop A? Well, we know the total is 100%, but there's no way to tell if that 100% actually represents 100 stickers. Okay, because no value is given. They're all like in this pie chart, we can only see percentage. So we can't tell. Okay, no value is given. So shop A sold more pastel stickers than shop B. Pastel stickers in shop A is 13%. Pastel stickers in shop B is 10%. Is it true that 13% is more than the 10% in B? We can't tell as well. Maybe the total for A is actually like so much more than B. Or it could be very much less than B. Okay, we cannot tell because no value is given. So not possible to tell. The percentages itself is talking about different totals. So it really depends on what that actual total is. Next, 25% of the stickers shop A are rainbow stickers. Is it 25%? Now 25% is 1/4. So is the rainbow a quarter of the whole thing? So in terms of percentage, we have 13, 25, and 40. Will rainbow take up 25%? Now, if you like to calculate out, then 100 minus 40 minus 25% minus 13%, this will give us 22%, which is not 25, right? So this is false. Question 5, Mrs. Tan prepared some sticks of satay and muffins for her students. The ratio of the number of sticks of satay prepared to the number of muffins prepared was 3:1. Each student was given 5 sticks of satay and 2 muffins. There were 52 sticks of satay left after all the muffins were given out. How many students are there? Okay, so in terms of the total prepared, total, satay to muffin 3:1. But in terms of the amount given, satay to muffin 5:2. Because every student was given 5 sticks of satay and 2 muffins, right? So it doesn't matter how many students are there, the ratio is always 5:2 if everyone is getting the same thing. Okay, so 5:2 is the total ratio for the amount that's given away. However, the what is left, right? For satay, it's 52 sticks. But for the muffins, nothing is left. Okay, so first, let's find the common base between these two ratios. If there are no muffins left, it means that whatever is prepared is the same as the number of muffins that were given out. Right? So because there's no leftover. So everything, all the muffins prepared is whatever that is given out. So your common base is the number of muffins. So we're going to make it the same. Make common base the same. So times 2. You get this. So the muffins prepared is the same as the muffins given away. But the total number of sticks of satay prepared is not the same as what's given away. Because you have still 52 sticks of satay left, right? So actually the amount left plus the amount given away is the total amount that is prepared. So the total amount prepared minus away what is given away is 1 unit. And that 1 unit will be 52, will be the amount that is left. Okay, so question asks how many students are there? Let's find the number of the total number of muffins first. So the number of muffins, which is the 2 units. So 52 times 2, which is 104. There are 104 muffins. Each student was given 2 muffins. So the number of students will be 104 divided by 2. So actually there are 52 students. Okay, so this table shows the cost of parking in SC Mall, Monday to Thursday, Friday to Sunday. So for part A, on Tuesday, Mr. Salim parked his car for 3 hours in the car park, starting from 8:30 a.m. So how much did he pay? If it's on Tuesday, we should look at the first row. Okay, ignore the second row for now. So he parked for 3 hours. The very first hour is $2.70. Okay, so only one time of this 270. So if he parked for 3 hours, then 1 hour is for the 270. The remaining 2 hours will be at $1.30 for every 30 minutes or part thereof. Okay, so for these 2 hours, how many sets of 30 minutes? So 2 hours divide by half. So can you count like how many half an hours are there in 2 hours? That will give you 4. So we have 4 times of 130. Which is 520. Now the total amount of money, remember to add back the first hour. So 520 plus 70. Okay, so for part A, 790. For part B, Jamie was charged $12.05 for parking her car in the mall from 10 a.m. on a Saturday. So what is the possible time she left the mall? So if it's Saturday, we use the second column. $12.05, definitely more than 1 hour, because the first hour is 260. Let's minus off and see what's left. $9 and 45 cents. So this $9.45, right, is for this at a rate of 189 for every 30 minutes. How many sets of 30 minutes is there? So we have to take 945 minus 1, divide by 189. To give us 5. So there's actually 5 sets of 30 minutes. At most, 5 sets of 30 minutes. Okay, it can be like 4 sets of 30 minutes plus few more minutes. Then it's considered as 5 sets, right? So let's see what time did she leave the mall. 5 times of the 30 minutes is 5 times half an hour. So for the 189, it's a total of 2.5 hours, then plus the 1 hour that we are supposed to add, right? So this is 3 hour, 3.5. So let's draw the timeline starting from 10 a.m. 3.5 hours, so 3 hour, 30 minutes. This is 1:30 p.m. Okay, so the answer can be 1:30 p.m. It cannot be more than that because park that off, right? If she parks more than that, then it will be charged another 189. But it can be shorter than this as long as it doesn't reach like the previous 30 minutes. Okay, so anything from as long as it's past 1 p.m. So from 1:01 p.m. to latest 1:30 p.m. Question 7. The bar graph below shows the number of cars sold from January to March. Number of cars sold in March is 1/4 the number of cars sold in April. Draw and shade the bar representing the number of cars sold in April. Okay, so if March is 1/4, means that April is 4 times. So, okay, let's count how many for each bar first. Okay, how many cars are there for each bar? So between 0 and 10, there are 5 intervals. So each interval is a +2. So for January, it's a 32. For February, it's 20 minus 2, so 18 here. And for March, it's in between 8 and 10, so it's a 9. So April must be 9 times 4, okay, 36. So you're supposed to draw a bar graph that goes up to 36. So it should be here. Okay, so it should look something like that. Next, what is the average number of cars sold from January to April? So to find average, we need to find total first. And total is 32, 18, 9, and 36, which will give us a total of 95. So the average of the 4 months will be 95 divided by 4, 23.75. So the number of the average number of cars will be 23.75 cars. Okay, it doesn't matter if it's not a whole number because the average is just it's just a number, not the actual number of cars. Okay. All right. Question 8. Radius of circle A is 3 times the radius of circle B. So A makes 12 revolutions to roll from X to Y. How many revolutions will B take from X to Y? Okay, so for A to roll 1 revolution, right? B will have to will definitely roll more revolutions, roll more rounds, right? Because the distance covered by A when it rolls will be the same as the circumference. Like the circumference is this much. So it will roll that the equivalent distance from X to Y. So for X, right, the circumference is actually a lot smaller. So how many times will X take to roll to be the same? Sorry, how many times will circle B roll to be the same number of to cover the same distance as circle A? So they say that the radius of A is 3 times the radius of B. So this is like 3 units, then this is 1 unit. So this means that the diameter, okay, the diameter 6 versus 2, right? It's also 3 times the diameter of A. Is equals to 3 times of the diameter of B. And if the diameter is 3 times, means that if 3 times. So because circumference is pi times diameter, right? So if the diameter is 3 times, means that the circumference will also be 3 times. So the circumference of X, I mean A, circumference, the circumference of A is also 3 times the circumference of B. Which means that every one round that A makes, right, X will have to make 3 times to make up for it. Okay, so every one round for X, A. Okay, one revolution for A. One revolution for A is actually 3 revolutions for B. So if A makes 12 revolutions, then B will have to make 3 times as much. So 3 times 12. Okay, so answer 36 revolutions. Part B, the radius of circle A is 12 cm. What is the length of XY? Okay, so let's look at circumference. So circumference means we need the diameter. So the diameter is 12 times 2, 24. Circumference is pi. What's pi? Pi is 3.14. Okay, 3.14 times the diameter, which is 75.36. So circle A rolls 12 times, right? So times 12. Okay, so 12 times 75.36. 904.32 cm. Question 9. Okay, so in the figure below, we have a square overlapping a trapezium. AB is parallel to DC. Let's mark that out. So also with a square, you have 4 equal sides. 4 equal sides, 2 pairs of parallel lines. You have a 25, you have a 33, find angle X. Okay, within a square, if you're cutting it diagonally into half, right, then the right angle is also cut into half, only for squares. Right? So to find angle X, this is 45, this is also 45. So we'll take 45 minus 25. So X is 20 degrees. B, find angle EBF. EBF is over here. Okay, so Firstly, to find EBF, let's find FCH. Because if we can find angle FCH, right, then using interior angle, you can actually use 180 because angles between two parallel lines adds up to 180. So 180 will be this and this, then you minus away FCH to get EBF. So how do we find angle FCH? Look at this triangle here, FCH, triangle FCH. Now remember, this is a square, right? So the angle here, right angle, is being cut into half, which means that this is a 45. So to find FCH, this angle, we'll take 180 minus x minus 45 minus 33. X is 20. So angle FCH is 180 minus 20 minus 45 and minus 33, which is 82. So this over here is 82 degrees. So as I've said, between two parallel lines, the angles add up to 180. So to find EBF, we take 180 minus 82. It's 98 degrees. Okay, so answer 98 degrees for angle EBF. Question 10. A car and a bike set off from town B in opposite directions at 9:30. Car traveled towards town A at constant speed of 80 km per hour, while the bike traveled towards town C at a constant speed of 62 km per hour. When the car reached town A at 12:30, the bike was still 28 km away from town C. So how far did the car travel? Okay, so things to note in this question. Firstly, they started off in town B. So B is between A and C, okay? So started off from town B. Car is going towards A. Bike is going towards C in different directions. Since the question is asking us for the car, right? Let's look at the car. Car traveled towards A at a constant speed of 80 km per hour. The car reached town A at 12:30. They started off at 9:30. So we know how long the car took, right? Which is like 9:30 to 12:30. We also know the speed of the car. So with the time and the speed, you can find the distance, which is how far the car traveled. Okay, so the time taken is 9:30 to 12:30. So 3 hours. Distance is speed times time. So your speed is 80 km per hour. The time taken is 3 hours. So total distance 240 km. Okay, so what's the distance between town A and C? Okay, so to put it in a diagram, let's say B is here, A is here, C is here. Not exactly half, but yeah, okay, just take note of that. So towards the left, towards A, right, the car. So the car traveled all the way, but the bike didn't travel all the way. So it was like 28 km away from C. Okay, then the car traveled 240 km, so that we have found. The only part missing is this part traveled by the bike. Okay, so you need to find the distance covered by the bike. The bike traveled at 62 km per hour. So we take the speed times the time. Time taken is also 3 hours earlier. We found earlier from 9:30 to 12:30, 3 hours. So the distance by the bike will be 3 times 62. So 186 km. So this is 186 km. Okay, so what's the total distance? I can add them up. So 240, 186, and 28. 4, 5. Okay, so 454 km is the answer. Okay, question 11. An packed all 732 cookies in a mixture of large and small boxes. He filled each large box with 30 cookies and each small box with 22 cookies. All the boxes are filled with no cookies left over. So what is the least number of boxes used by An? Okay, this looks somewhat like a supposition question, but we are not able to use supposition for this question because usually supposition actually tells us like what is the total number of boxes. In this question, no, the total number of boxes is not given. Okay, and we have to figure out what is that total. And also ensuring that all the cookies are being put into the boxes. Okay, so not just any number, but the least number of boxes. So to get the least number of boxes means that you want to have as many large box as possible, right? Then you can have like more cookies into a box. Okay, so the maximum number of large, let's find that first. The maximum, the highest we can go. Maximum number of large boxes will be 732 divided by 30. Each large is 30. So this will give us 24 boxes. Remainder 12. Okay, what this means is that if you put all the cookies, if you put as many cookies as possible into large, right, you end up with 24 large boxes. But there is this extra 12 that is not inside the large boxes. Now, whatever that is left outside of the large boxes is supposed to go into the small box. But all the boxes are supposed to be fully filled. So this remainder, having to fit into the small boxes, right, must be, so remainder be a multiple of 22 in order to fit nicely into the small boxes. Okay, so this is our starting point. We start off with 24 large boxes. Your remainder will be a 12. Is this a multiple of 22? No, it's not. Okay, then next, we cannot go any higher, but we can go lower. So we go one box less. 23 large boxes. So this means that I'm removing all the cookies in one of the large. Okay, and then the cookies that I've removed will join the remainder. So each large is 30, right? So I'm actually taking out 30. The remainder now has 30 more, which is 42. Now this 42 will not fit nicely into the small boxes because it is not a multiple of 22. Then next, let's go one less for the large boxes, okay? So every time I take away one large box, I'm actually removing 30 from the boxes. 30 will go to the remainder. So 42 plus 30. This again is not a multiple of 22. You can use your calculator to check. Okay, then next go one more large box down. We add on 30 again. So 72 plus 30. Okay, 22 is 102 is also not a multiple of 22. So one more time. And we add 30 again. Okay, this time 132. If you divide by 22, you actually get a nice number. So this is actually a multiple of 22. So one number. So number of small boxes is 132 divided by 22. You'll get 6. So total number of boxes, they're asking for the least number of boxes. So there are 20 large plus 6 small, total 26 boxes. Question 12, in the figure below, ACE is a triangle, BDEF is a parallelogram, and we have an isosceles triangle. AE is parallel to BD. Okay, let's find that out. AE and BD. Okay, because parallelogram also, right? So we have these. Okay, find angle GBD. Now, GBD, this whole thing here, is actually 180. Angles on a straight line, 180 minus 22 minus 58. So give us 100 degrees. So that whole thing there is 100. Find GBF. Okay, so to find GBF, what do we need to find first? So if I have isosceles triangle here, right? If I can find BGF, this angle here, that is technically the same as this because they're isosceles, then I can find GBF. So how do I find BGF? Okay, so I have parallel lines. So angles between two parallel lines adds up to 180. So earlier we found that this is 100. So now this angle here, BGF, is 180 minus 100. So this is also 80 degrees. So angle GBF is 180 minus 80 minus 80. Okay, so 20 here. Find BDC. BDC, this angle over here. Now, BDC is actually the same as this FBD because, okay, let's highlight it. So you have parallel lines here, here. So looking at this, okay, I'll just highlight here. see like a Z, right? So that's your alternate angles. And it only works if you have parallel lines. FB is parallel to DC. So if they are parallel, then that is the same as this. BDC is equals to FBD. So let's find FBD. FBD is 100, oh, okay, 100 minus 20. Which is 18. So this is 18. Actually, alternatively, you can also look at alternate angles over here like that. So this 80 here is the same as this 80, so we know that they are equal. And now this and this angle, they're alternate angles. So this is also 80. Okay, so BBC is also 80 degrees. Question 13. Freddy had a rectangular block measuring 10 by 3 by 6 cm. He painted all the faces of the block. Calculate the total painted area. Now let's look at bottom and the top. Over here. So that is 10 times 3. Then we times 2. Okay, so 30 times 2. Because top and bottom. Then next, we have the front, the sides. Let me do the sides first. Yeah, and here. So that's 6 times 3, 18. And we have both sides. So 18 times 2, 36. Then lastly, we have this here. Then at the back as well. Okay, so front and back, which is 10 times 6. So that times 2 is 120. Now we add everything up. So 60, 36, and 120. 216. Total area painted 216 square cm. Okay, so Freddy wants to cut the largest possible cube from the rectangular block. What is the greatest number of such cubes he can cut from the rectangular block? Okay, the largest possible cube that you can cut depends on the shortest side of this rectangular block. The shortest side is 3 cm. So the largest possible cube has to be a 3 times 3 times 3. Okay, because nothing bigger than the shortest side. Now, how many 3 times 3 times 3 cube can you get from this figure here? So what we do is we're going to find out along the length, how many can we get? Along the breadth, along the height, how many can we get at most? So for the length is 10 cm. So 10 divided by 3, which is 3R1. So maximum you can get 3. And the breadth is 3 cm. So 3 divided by 3, you can get 1. Then lastly, the height. The height is 6 cm. 6, right? Okay, so 6 divided by 3, which is 2. Okay, at this point, we want to use the 3, 1, and 2. Do we add or do we multiply? So along here, you can get maximum 3. Here, 1. How high can you go? 2. So it's like 2 layers of 3 times 1. So 3 times 1, 2 layers, so times. Okay, so answer maximum can get is 6 of such cubes. The question 14, tank A and tank B are shown below. So they are empty at first. Tank A had a base of 441 square cm. So when water is being poured into tank A, some of the water flowed into tank B through this hole here, which is just above tank B. Then tank B became 4/7 filled. The total amount in the water in both tanks became 5324 cubic cm. So find the amount of water in tank A. The amount of water in tank A, right, for it to overflow, for it to flow to B, it will have to reach up to that height. And it just can't be able to fill more than that because of the hole. Okay, so what is the amount of water in tank A? How high can it go? Since tank B is 4 cm tall, tank A can only go up to 4 cm tall. Okay, then we take the base area, which is 441, times the height. So volume is 1764 cubic cm in tank A. So for part B, what's the capacity of tank B? Total volume of water in both tanks is 5324. We already know the amount in tank A, so let's find the volume of water in tank B. So we take 5324 minus 1764. 3560 is the volume of water in tank B. And according to the question, this is 4/7 filled. So that is 4/7 of B. So we want the capacity of B, which is like 7/7 of B. Okay, so if I want 7 first, 3560 divided by 4. 890, then 890 times 7. 6230 cubic cm. Question 15, there were 600 adults attending a concert at Fort Canning Park. After 5/8 of the men and 165 of the women left the concert, the ratio of the number of remaining men to the remaining women became 1:7. So what was the ratio of men to women at first? Okay, so we start off with the total at first. So let's do before change after. Total at first 600. Now there is a change. For the men, 5/8 of them left. Minus 5/8. 5/8 is what we call a proportion. Okay, this is a proportion transfer. For proportion transfer, we have to do our before change after bit. B, C, A. Take away 5/8 means that you started off with 8 units. You are taking away 5 and you're left with 3. Okay, the before, change, and after. For the women, 165 left. 165 is not a proportion, it's just a value. So you just need to write down minus 165. Okay. Then we have the ratio of the remaining men to women, 1:7. So from here, every time you have more than one set of ratio, you need to find common base. So what is the common base between this ratio and this ratio? This ratio is talking about after. So we are looking at men in the end. Okay, the men in the end here is 3 units, but over here it says 1 unit. It represents the same thing. So we have to change this. Okay, so change to 3 units. Now, what we're going to do next is I'm going to go from left to right. Starting with 600. Then we take away 5 units. We take away 165 to end up with 24 units. So in an equation, 600 minus 5 units minus 165 equals 24 units. Now I'm going to rearrange them, put all the numbers first. Then I'm going to work on this first, which is 435. Keep everything else. So by looking at this equation, what is 435? 435 is actually 29 units. Not 19, 29. So since we have 29 units, we can find 1 unit. One unit is 15. What is the ratio of men to women at first? Okay, so the number of men is 8 units. Men at first, which is your 8 units. So 8 times 15, 120. Women at first, from our before change after, we know the total at first is 600. So 600 minus 120, 480. Now let's write down the ratio of men to women. One 120 to 480, simplest form 1 to 4. Question 16. Figure below is formed by 2 quadrants and a rectangle overlapping one another. The radius of the smaller quadrant is 10 cm. Find the area of the shaded part of the figure. Okay, so the smaller quadrant is like here, and the bigger one is here. So let's cut this diagram. Okay, I'm going to cut it this way. So like in this quadrant, right, there's actually a triangle. And then this is what we call a half petal. So in the bigger quadrant, I'm going to cut this line all the way up. Okay, let's name this A. Let's name this B. And then C. So A is what we call half petal, where we have a quadrant, we take away the triangle. Looks like half of a petal. B is also half petal, but it's of the bigger quadrant. And then C is a triangle. Okay, let's find each of the parts. Let's look at A first. To find A, we need to find the area of the quadrant. Then minus away the area of the triangle. Okay, so the small quadrant is 1/4 times pi times radius, which is the 10 times radius. here you get 78.5 for the small quadrant. Then minus away the triangle, which is half times 10 times 10. Is 50. And the area of A would be 78.5 minus 50. 28.5. Next, we find the big quadrant. In order to find the half petal for B, okay, the B is the half petal. Okay, so the big quadrant, we need the radius, which is different. The radius will be 14. As here is 10, this 4, right? So radius 14. So big quadrant is 1/4 times 3.14 times 14 times 14. 153.86. Then we are supposed to take away the area of the triangle, the big triangle, which is half times 14 times 14. 98. So area of B will be big quadrant minus the big triangle. 55.86. So the last thing we need to find is the area of C, which is half times 4 times 4. That gives us 8. So we are adding A, B, and C to get the total shaded area. (92.36 square cm). Okay, last question. Mr. Wong bought a number of red, blue, and green balloons. The ratio of the number of red to blue to green was 15 to 12 to 28. After busting some green and buying another 168 blue, he found that there was a decrease of 25% in the total number of blue and green balloons. So in the end, the red, blue, green, total 1440. Okay, so let's do, since we're given the ratio at first, and then there's a change, right? There's some increase and decrease. We do before change after. Okay, starting off with the ratio red to blue to green. Fifteen, 12, 20. Okay, some green after bursting some green. So green minus question mark some. And for the blue, plus 160. Now there is this decrease of 25% in the total of blue and green. 25% has changed to fractions, which is 1/4. So this blue and green, right? Overall, so let's do a combined one. Blue and green decreased by 1/4. So minus 1/4. Now 1/4 again is a proportion transfer, right? It's a proportion of something. So with proportion transfer, I need to do my before change after below it. So take away 1/4 means that I start off with 4 units. I take away 1 unit and I'm left with 3 units. In the end, the total is 1440. So here I have ratio. Here I also have ratio, right? So whenever you have more than one set of ratio, you have to find a common base between them. So what's the common base between these two ratios? This ratio is talking about the before. This ratio has before, change, and after for the total of B and G. So I need the before for B and G. Blue and green. So here, blue and green is 12 plus 28, which is 40. It's supposed to be 40 in total. The total number of units at first, B and G. So here, B and G, your total at first should be 40 as well. Okay, that's what I mean by making common base the same. So it becomes 10. Okay, so with this, right, I know my blue and green will change, but my red didn't change. So the red in the end will still be 15 units, whereas the blue and green is actually 30 units in the end. So what we can do is can write down blue plus green to red. Blue and green is 30 from here. Red no change, so 15. So don't simplify this because these these units came from the other ratios, okay? So you want them to have that link. Don't simplify it. You remove that link instead. Okay, so how many units is 1440? 1440 is 45 units. Then find 1 unit. Divide by 45. You get 32. How many did he have at first? Okay, the total at first. We add them up. Your red, blue, and green over here. Add them up. Or you can do blue and green plus red. 40U and 15U. Which is 55 units. So 55 units is 55 times 32. 1760. So that's the total number of balloons at first. Okay, so how many green balloons burst? Now, if you take a look at this, right, there is the overall decrease. So how many balloons burst? Okay, let's find out what's the overall decrease. The overall decrease is 10 units. Ten times 32, 320. Okay, so overall, the blue and green actually dropped by 320. But you know the blue actually increased, not decreased. So it means that green will have to drop by more than 320. Okay, so green dropped by a lot. Then blue increases instead by 168. The overall decrease is 320. So green cannot have a decrease of just 320, okay? It's more than that because it needs to like counter in a way, in a sense, counter this increase of 168. Okay, so the decrease in green is not just 320, but on top of that, plus another 168. So the green actually decreased by 488. The blue increased by 168. So that's why there is an overall decrease of 320. Okay, so with that, this is the end of the paper 2 for SCGS Prelim paper 2023.